Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this particular video, we're going to talk about the sum of the first n terms of a geometric series. Let's start. There are two different formulae for the sum of the first n terms of a geometric series. And it all depends on the r, the common ratio. If the absolute value of r is less than 1, we use this particular formula. I'm going to write it down here. Sn is a 1 minus r to the power of n over 1 minus r. You use this formula when the absolute value of r, the common ratio, is less than 1. A is the first term as always, and r is the common ratio. Okay, this is the sum of the first n terms for a GP, a geometric progression. Whereas you'll use the formula a times r to the power of n minus 1 over r minus 1. This formula when the absolute value of r is greater than 1. So two different formulae. You have to pay attention to the value of r, the common ratio, and use the formula accordingly. Let's illustrate this with an example. We are going to solve this question which says find the number of terms in each of the following geometric sequences. We've already seen a question like this in the earlier video, and using n, the number of terms, we are going to find the sum of the first n terms using one of these formula depending upon the value of r, if it's less than 1 or greater than 1, okay? So let's go ahead with that. We've got the terms as 4, 12, 36, dot, 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 and the last term given to us is 2, 3, 6, 1, 9, 6, all right? We are going to use the same strategy. So first let's find out what that r is, okay? So for doing that, we divide the second term by the first term. We say that's 3. And just make sure that it is a common ratio, the ratio of each successive terms. So let's do the same thing for the third term and the second term. The ratio of the third term to the second term is going to be 36 over 12. And that also happens to be 3. So that confirms that it's a geometric sequence with common ratio 3. We write it down. This is a GP. R is 3, and we are going to write down this value greater than r is greater than 1. So that justifies why we're using a certain formula. But before we use the formula, we need to find out what n is, right? We need to know the value of n. So let's do that. We make use of the formula for the nth term. Un is a r to the power of n minus 1 for a GP, and a we know is 4. So that's going to be 4 times 3 because that's the common ratio to the power of n minus 1. So this is going to be the nth term for this particular GP where r is 3 and the value of a, the first term, is 4. And then just as we saw in the earlier video, we can use this general formula equating it to the last term given here to find the value of n, all right? So we can say 4 times 3 to the power of n minus 1 equals to 196 would then give 3 to the power of n minus 1 is equal to 236196 divided by a 4. That value should be 520, that's 9, and then a 0, 4, 16, 17, okay, 9, okay, 59049. That means 3 to the power of an n minus 1 is equal to 59049. Now, that means you just need to figure out what power of 3 is going to be 59049. For the sake of time, I had already worked it out. It's the 10th power of 3 that will give you 59049. You can easily work it out using the prime decomposition of 59049 and work out that 3 to the power of 10 gives you 59049, which means this is going to be 3n minus 1 is 3 to the power of 10. And then when you compare the indices on both sides, you can say n minus 1 is equal to 10, which means n is equal to 11. That means that the 11th term, this is the 11th term of this geometric sequence. And that is what we want to find out. We want to find out S11, the sum of the first 11 terms. So that's the formula we're going to use, right? That's the formula we're going to use. S11 is going to be equal to A. Our A was 4 times r. Which formula are we going to use? We're going to use the formula r to the power of n because r is greater than 1, okay? Because here we have r is equal to 3, right? So we're going to use r, which is 3 to the power of n, which is 11, minus 1. Be careful with this formula, how we're using it, okay? Because this minus 1 is not to the power of, because in the general term, we have r to the power of n minus 1. Do you see that? just going to highlight that, okay? This is r to the power of n minus 1, whereas here in the formula for the sum of the first n terms, it is r to the power of n. The minus 1 is not in the index, it's the term following it, okay? And that divided by r minus 1, okay? Use the same color, 3 minus 1. That's how you use the formula. And here we use this formula, this version of the formula, because r is greater than 1. And then it's just about simplifying this further to get 4 times 3 to the power of 11 is just multiplying 59049 by 3. And that should be 177147 minus 1. And that's 2 here. That can be further, you can get a 2 and 2. And that should further simplify to just 2 times 177146. And that's just multiplying these two numbers, which should give you 2, 6, 12. 2, 4, 8 plus 1, 9, 2, 1, 2, 2, 7, 14, 2, 7, 14 plus 1, 15, 2, 1, 2, 3, 3, 5, 4, 2, 9, 2 should be the sum of the first 11 terms. And this sum is what we call the 11th partial sum. The nth partial sum, if you remember from the video, I'm going to link those videos in the description box below, okay? S11 is also called the 11th partial sum, which was also known as the series. Okay, series, depending upon the sequence. If it was a geometric sequence, as in this case, this is called a geometric series. The sum of the first 11 terms of that geometric sequence is called the geometric series up till the 11th term. Now, let's take one more question quickly. The third term of a geometric sequence is 36. All right, so let's write it down. This is a GP. This is always a good habit to write the statement. This is a GP. They've said that the third term, U3, is 36. And they've given that the 10th term, U10, is 78732. All big numbers, but nothing to be afraid of, okay? Find the first term in the sequence and the sum of these terms. Again, interesting question. So let's make use of the appropriate formula. You have the nth term, the formula for the nth term, U3 is 36, so that we can write a times r to the power of 2 should be equal to 36, okay? A times r squared, because a times n minus 1. And then when you have U10 is equal to 78732, you can say a times r to the power of 9 will be equal to that 78732. Can you see what I've written here? Cool. Now, what we're going to do is that we're going to divide both of these equations. That's equation number 1. Equation number 2, we've seen a similar question in the earlier video. That is why I'm going a little faster, okay? So we're going to divide these two equations. Divide equation 2 by equation 1, and we'll get a r to the power of 9 divided by a r to the power of 2 is equal to 78732 divided by 36. And then from this equation, that a, the factor of a from the numerator and denominator on the left hand side can cancel off, and the left hand side reduces to r to the power of 7 is going to be equal to 2187. I've already worked it out so that this video will not go crazily long, okay? And then, of course, as I said before, you can find the prime decomposition factors, and you'll find out that it's actually the power of 3 to the power of 7 that'll give you 2187, which means r, again in this example, is 3. Also make a mention that it's greater than 1. Why we use a certain formula? You need to say that r is equal to 3, greater than 1, because there are two versions of the formula, right? And then we can find the value of a by using this value of r in any of these equations. We'll just put it in equation number 1, say substituting in equation number 1, we'll get a, that's the unknown, r is 3 as we found out, is going to be equal to 36, which means a is 36 over a 9, which is 4. Very similar to the earlier question, a is 4, and the common ratio is again 3, all right? So now we have to find the 10th term, I believe. Yes, they've given the question that the 10th term, all right? They gave the third term and the 10th term. They said find the first term and the sum of these terms. They already gave us the 10th term, the value of n, unlike the earlier case. So let's use that formula for Sn. Again, we're using the same formula because r is greater than 1 in this case. So S10 is what we're computing. A is still 4, and that's 3 to the power of 10 in this case, minus 1 over 3 minus 1. Just be careful with that 3 to the power of 10. I think sometimes students make mistakes in that, how they've written that. Because of that formula having those two versions, r to the power of n minus 1 and r to the power of n minus 1, where that minus 1 is whether it's the part of the index for the general term, and this is not part of the index for the sum of the nth term, okay? This is also the nth partial sum. And that when you simplify it further, you'll get 4 times 3 to the power of 10 is 59049. I had already worked it out. 3 minus 1 is a 2. And this also can be simplified as 2, 2, which is basically 2 times 59048. And when you multiply those two numbers, 2 and 8 is a 16, 2, 4, 8 and a 9, 2, 9, 18, 2, 5, 10. And that should be 11 actually. 118096 is going to be the sum of the first 10 terms of this geometric sequence, also known as the sum of the series up to the first 10 terms. If you found this video useful, do not forget to like, share, and subscribe to this channel. I'm going to see you all in the next video.